Hello everyone, welcome to fifth session on numerical analysis of BSc fifth semester. In this session, we shall discuss about another important topic called as types of different errors associated with addition, subtraction and multiplication of two numbers. So let us have a recap of the previous session. In the previous session, we have discussed about the valid significant digits. And we have also solved a couple of examples which were involving valid significant digits. Now, in this session, we will be able to understand the concept of error associated with addition of numbers, error associated with subtraction of two numbers, and error in the multiplication of two numbers. That is the objective of this session. Now let us start with the first topic, that is error in the addition of two numbers. Now let us suppose that x and y are the two numbers given to us with the approximate values of x and y as xa and ya respectively. So you have to understand xa is the approximation of x, ya is the approximation of y. Now what is the error in their sum? What is the error associated with the sum of x and y? That is given by, as usually, the definition actual value, exact value minus the approximate value. Exact value is exact value of x plus exact value of y minus approximated value of x plus the approximated value of y, the sum we are considering. So this is the sum, that is the error associated with the sum. Now if we simplify this by taking xa with x, that is x minus xa plus y minus ya, we have separated by using the associative property, we have separated the brackets. Now we know that this x minus xa is nothing but ex, error in the value of x, that is x minus its approximate value. Similarly, y minus its approximated value is error in the value of y. So therefore error in the value of sum is the sum of the error in the two numbers x and y. So here ex and ey are the errors in the values of the numbers x and y respectively. Now after defining the sum, that is the error in the sum, let us define the absolute error in the sum. So the absolute error in the sum is, we know that absolute error is the absolute value of the error. So simply we have to take absolute on this particular value, that is the absolute error in the sum. And we have one important inequality, absolute of a plus b is always less than or equal to absolute of a plus absolute of b. By using that inequality, we are having this particular expression over here. Now when we simplify this, when we use this in the definition of relative error, we will have please look at this. This is the expression for relative error. So what is the expression for relative error? Relative error is absolute error divided by the absolute value of the sum here, that is x plus y. So it is ea divided by absolute of x plus y. So it is ea is here absolute of x, it is less than or equal to ex plus ey, modulus of ex plus ey divided by x plus y we can take, or otherwise we can directly write ea is nothing but this particular thing, that is ex plus ey here divided by modulus of x plus y, and that we can take single absolute, that is modulus of ex plus ey divided by x plus y. So this is how we can get the value of absolute error and relative error associated with the addition of two numbers. Now let us have an error associated with subtraction. Now Again, x and y are two numbers and their approximations are exa and ya. Now error in the difference. Error in the difference is, ed stands for error in the difference. It is nothing but difference minus difference of the two exact numbers x and y minus difference in the approximations of x and y respectively. So this is the definition of ed, and here again when we separate the brackets we get x minus xa. This is nothing but ex, error in the value of x, by looking at this bracket. Again minus sign as it is here. Y minus ya is error in the value of y. Now if we look at the definition of absolute error is very simple. It is absolute of the error. So if we take the absolute of this, we are having over here this thing. Now by using one of the inequalities, this is greater than or equal to modulus of ex minus modulus of ey. This is known from our previous studies. So absolute error in the difference of two numbers is always greater than or equal to absolute error in x minus absolute error in y. Or else we know that absolute error in ex minus ey is less than or equal to, we can take this is less than or equal to absolute error in ex plus, we can instead of minus sign, if we have plus sign here in between ex and ey, it will be less than or equal to, the inequality will be reversed. So we can say that maximum absolute error in the difference is always less than or equal to absolute error in x plus absolute error in y. So that is another definition we are having over here. Now what is the relative error? Let us see. So relative error is again absolute error divided by absolute of x minus y. So this all of us know. Absolute error divided by absolute of x minus y. Absolute error, we have seen that it is absolute of ex minus ey divided by absolute of x minus y as it is in the denominator. And again, as I have told you, absolute of ex minus ey is less than or equal to absolute of ex plus, this should be taken as plus, absolute of ex plus absolute of ey divided by absolute of ex minus ey. So the maximum relative error in the difference of two numbers is always less than or equal to absolute error in ex plus absolute error of y divided by modulus of x minus y. So this is the maximum relative error in the difference of two numbers. So this is how we have defined the relative error and absolute error in the subtraction of two numbers. Now let us try to have another definition, that is error in the multiplication of two numbers. So here again x and y are the two numbers whose approximations are xa and ya. Now their product, error in their product we are computing. We are computing the error in their product. So that is equal to actual value of the product minus approximate value of the product. Now let us take this bracket to the other side. So em as it is, take this xa to the other side, it becomes minus xa, it becomes minus xy. So em minus of bracket x minus y, it becomes, when it comes to here it becomes like this, minus, see this xa minus, this is minus of, here it should be minus sign, please take the minus sign over here, minus xa ya remains on RHS. Now em minus xy is equal to, we know that this minus sign should be kept here as it is. Now xa, we know the definition of error in x. Error in x is x minus xa. So therefore xa is x minus ex. Again ya is, by using the same definition, we know ey is y minus ya. Therefore ya is nothing but y minus ey. Using the simple definitions of errors, we can have the value of xa and the value of ya like this. Now if we multiply these two brackets together, xy term comes there in the product, xy terms, so that xy cancels with this xy, and the remaining terms when we simplify, you will have on RHS exy plus yex, on LHS it is em. So the definition of the error in the multiplication is this much. Now with this in our hand, we can have a definition of absolute error as well as relative error. Absolute error is very simple. Take the absolute on this thing, that will be the absolute error. So relative error is absolute error divided by the absolute of the value xy. So absolute error. So we have to take the absolute on this. We have to take the absolute on this. So that gives us the numerator absolute error, the EM. So absolute error, absolute of the error in the product, that is over here, denominator as it is. Now when we simplify this by by taking the single modulus and then separate division, gives us xey divided by xy plus yex divided by xy. If we separately divide it, so after cancellation x we get ey by y plus ex by x. Y cancels in the second term, it is ey divided by ex divided by x. So this is the relative error in the value in the computation of product of two numbers x and y. Now here we have to note down one important thing, that without going to define literally what actually the error in the quotient of two numbers, we can directly take down the relative error in the quotient is this much. So instead of equal to, we are having here less than or equal to modulus of ex by x plus modulus of ey by y. So the maximum relative error in the quotient of two numbers is is less than or equal to modulus of ex by x plus modulus of ey by y. So these are the definitions we have over here. Let us use these definitions to solve a couple of examples. So let us go for the first example. So the first example is here. Let us try to solve this. If this is the number x, if 0.2222 and 0.5714 are the approximate values. See, these are the approximate values of two numbers. The first number is x, this is to be taken as x, here we have taken. This is the second number, which is to be taken as y. And their approximations are, this is the approximation of x, therefore it is to be taken here as xa. This is the approximation of y, so this is to be taken as ya. So we have collected the data, and with the data in our hand, we can compute the absolute and relative error in their sum. So this is very important, we have to consider their sum. So absolute error in the sum we have seen in the previous section, that it is less than or equal to modulus of x minus xa plus modulus of y minus ya. So this definition we have to use, and we have to substitute the values. X value is 2 by 9 minus xa value is 0.2222 plus sign as it is. Again absolute of this y value is 4 by 7 as per the data, minus ya value is here we have collected. So if we simplify this, we can get the value of, we can get the simplified value as 0.00005. You can use the calculator and get the value as 0.00005. This is the absolute error we have computed. Similarly, the relative error. Relative error is absolute error divided by modulus of x plus y. We have computed in the previous step that absolute error is absolute error is in the numerator, and we have to substitute the absolute error. Its value we have computed in the previous step as 0.00005 divided by modulus of, it is absolute, both values, 2 by 9 the value of x, 4 by 7 the value of y, both are positive, therefore no need of writing the absolute sign again. So simply take like this, take the LCM, you will get the answer 50 by 63, and simplify this by using the calculator, you will get the answer 0.00063, which can be written as 0.63, only these things. So we can shift the point, how many places here, 1 2 3 4. So after shifting point to 4 places to the right, we have to write 10 to the power of minus 4. So the final answer is 0.63 into 10 to the power of minus 4. This is the relative error in the sum of the given two numbers. So this completes the solution of first problem. Now let us go for the second problem. So the second problem is to find the difference. Look at the question here. find the difference between square root of 3.28 and square root of this value. So here two values are given. X value is this thing, y value is this thing. So x is this, y is this, and if we look at the calculator, it shows the value of root of 3.28 like this, with infinite, with dot after this. So there will be infinitely many decimal places, and the value of square root of 3.27, that is y, is looking like this. So now these are the actual values, exact values with the dots afterwards here. Now we want to restrict ourselves to 3 places after decimal digit. So we want to have only 4 valid significant digits, or we want to stop at 3rd place after the decimal point. So 1.811 and here 1.8908. Sorry, 808. So these are the approximated values of x and y respectively. Now we can have the difference, we can find the difference of these two. So sorry, the difference of these two actual values. So the answer will be 0.003 dot something will be there, but we want to have only 3 figures after the decimal place, so we will have only 0.003. Now the difference is this much. We have computed the difference between these two places is this much. Now we have to evaluate. This is important part of the question. Evaluate the relative error of the this difference. What is the relative error of this difference if we keep 3 places of the decimal place? That is very important. So the maximum error in x and y. We have seen the concept of valid significant digit. In the concept of valid significant digit, we have seen that the maximum error in x and y, in that discussion we consider only x. Here we can say both x and y, because in both x and y we are retaining 4 valid significant digits. Therefore, it is half of the unit of the last digit. What is the unit of the last digit in both the cases? You see, unit of the last digit is 10 to the power of -3. This is 10 to the power of -1, 10 to the power of -2, 10 to the power of -3. Here also 10 to the power of -3. Even if you see here, it is 10 to the power of -3 everywhere. So it is half of 10 to the power of -3. That we have discussed in the previous sessions. Please look at those videos. Now, if we simplify this, it looks like 0.0005. So this is the maximum error in the value of x and y. So therefore we can take that value as ex and ey. So with this value of ex and ey in hand, we can proceed to the next step, wherein we are computing the maximum relative error in the value of their difference. We have seen the maximum relative error in the difference is always equal. We have seen the relative error is less than or equal to this thing. So if we write maximum, it becomes equal. So maximum relative error is equal to modulus of ex plus modulus of ey divided by x minus 1. We have computed ex as 0.0005 and modulus of ey as 0.0005 in the previous step. We have kept them as it is in the numerator. Both are positive, therefore we have written them directly. In the denominator, we have computed x minus y modulus. It is x minus y, we have computed it is 0.003 and we have kept it as it is. And now when we simplify, when we add these two, it will be 0.001, denominator as it is. Now it is simply 1 by 3. 1 by 3 means 0.0033, 0.3333, like that. So this is the maximum relative error in the computation of the difference of two given numbers. So this is the second problem we have completed. Now let us go for the third problem, where we have to find the product of these two numbers. This is also another important problem. Here we have to find out the product of x, product of y, and these are taken as x and y. You please see here. And we have to state that how many figures of this product are valid. Trustworthy means valid. How many valid significant digits are there? That we have to say when the numbers are correct to 4 significant digits. So here there are totally 4 figures. All the figures are to be taken as valid. So when we take all the digits as valid significant digits, because 4 is n here, when we take all the 4 digits as valid significant digits, then what will be the how many figures will be there which are valid in their product, that we have to compute. Now let us start the solution. So this is x, this is y we have taken, and we have seen that maximum absolute error is less than or equal to 0.5, that is 1 by 2 into the unit of the last digit. Unit of the last digit, you please see here, unit of the last digit is 2, unit of this last digit is 0.1, because it is 0.2, it is 10 to the power of minus 1. It is 10 to the power of, unit of the last digit is 10 to the power of minus 1, that we have taken in both the cases. It is 10 to the power of minus 1. Therefore, the absolute error is 0.05. So, Ex, Ey both are 0.05 we have computed. So, this is an important thing we have to keep in mind. It is the absolute error in X, absolute error in Y is always less than or equal to 0.05. Now, what is the product? Product of these two numbers is directly you multiply this with this. So, the answer is 51,107. 51,107 is the product of the two numbers. Now, what is the relative error in the product? The definition is maximum relative error in the product is Ex divided by X plus Ey divided by Y. In the previous step we have seen that Ex is 0.05, Ex value is 0.05, it is here, Ey value is the same thing, and we have substituted them, X value as it is, Y value as it is. So these two things are there. So this value when we simplify, it is looking like this, plus this value when we simplify using the calculator, it looks like this. So when we add these two, this is the final answer. So relative error, the maximum relative error is this much, or the relative error is less than or equal to this much, we can say. Now in the next step, so what we have to do, absolute error. What is the absolute error? Actually the relative error, first we define the relative error. You please look at this problem. In all other earlier problems, we used to define the absolute error first and then the relative error. But in this problem, we first find out the relative error and then we go for finding the absolute error. So absolute error is relative error into absolute value of X and Y, because relative error is absolute error divided by absolute of X into Y. So when we cross multiply, we get absolute error in the product is equal to relative error in the product into the absolute of X and Y. Here it should be absolute of X and Y. You please make a correction. Here it should be absolute of X into Y. That's trivial. Now ER value we have computed in the previous step. It is this much. Absolute of X into Y, it is positive value always. You keep it as it is. Now you multiply these two, you will get 25.485. This is very important step. So absolute error is less than or equal to 25.485. We know that modulus of Z, if it is less than or equal to A, that means Z value is in between minus A and plus A. This is the one important thing we know. So let me write it over here for your sake. If we write modulus of Z as less than or equal to A, it means that Z value is in between minus A and plus A. This is an important thing. By using this information, I am writing minus 25.485 is less than or equal to EP. So modulus of EP goes now, it becomes only EP. Error in the product is less than or equal to 25.485. Now the value of EP is in between these two. Now the actual value of the product. What is the actual value of the product? So product is 51,107. But error associated is minus 25.485 plus 28.485. So the meaning here is that our product is plus or minus of this quantity. It will be either minus of this quantity or it will be plus of this quantity. There is an error. So that particular thing is the actual product. So the actual product lies between these two quantities. So if we simplify this thing, it is here. When we simplify this, it is here. So our meaning here is the actual product lies in between this value and this value. So therefore, when we take the mean of these two, that is this plus this divided by 2, we get the answer as 51,107, that is the actual product of the given two numbers. That can be written like this in terms of decimal places. We can write if we want, or otherwise we can keep it as it is. So this is the product. This is the product of x and y we have computed using the concept of errors. So in this way we have solved all different types of examples on the topic of errors associated with some difference in product of two numbers. So here are few examples, a few questions you can answer to them later on. So please look at these questions. So you can solve more and more examples on this topic, and you can have a reference of this book for the sake of solving more and more examples. With this, let me stop. Thank you very much.